Okay, hello everyone. This is Salar. This is a tutorial for writing a real-time operating system, and we are in part 17. And according to the previous agreement, in this part, I want to turn on an LED on my board, okay, and debug my program because I've written a program by CMSys for my microcontroller for my chip, and it's a practical program, and I want to add some part to my code to turn on an LED on my board. Okay, a completely practical program by GCC in Linux and GCC and CMSys. Okay, first let's do open Zonal, and in this part I want to turn on an LED on my board and debug my program. Okay, so as you can see or don't see, I have a board and I have a microcontroller on my board. It's my MCU, and in my board I have a I/O port. Okay, in my microcontroller I have a I/O board, and in my board a green LED is connected to my board. Okay, and I want to turn on this LED, and this LED is connected to GPIO a general purpose input output peripheral pin 1. Okay, I want to set pin 1 to high level to turn on my LED. Okay, to turn on my LED. To turn on this LED, I should write some specific value, to some specific peripheral registers. Okay, some value to some registers. So for my board and for this microcontroller, first I should enable my peripheral clock. Okay, first I should enable peripheral clock. RCC is a peripheral for reset and clock control, and in register AHB1 ENR. Okay, I should write some specific value to this register to turn on my to enable clock of GPIO1. Okay, to enable clock of this peripheral. After that, for pin 1 in this peripheral, I should set my pin as an output pin. Okay, I should set as output pin to turn on this LED. After that, in GPIO I and a register that its name is moder. Set the mode of this pin and set the GPIO pin as output. You can have some mode in a pin, for example, input, output, analog, or other works. And in the last part, I should put high value to this output pin. Okay, another time in GPIO IODR register. Okay, I should put some value to this register to set the pin as a high level pin. Okay, set it to 1. 1 means 3.3 volt. Okay, and when I put 1 to this I/O port, I will turn on this LED on my board. Okay, I will turn on LED. I'm on my board. It's my board. You should know that STM32F746 discover. Okay, it's my board, and on my board I have a LED on my board. Okay, I have an LED on my board. After turn on LED, I will show my board on webcam to you. Okay, but so as I said, I should write some specific value to some registers. So how can I write a value to a register? Write a value to a register. Okay, how can I write a value to a register? In CMSs, you have a predefined function. Okay, predefined function. The name of function is underline STRT. Store thumb. Okay, store thumb. This theme is thumb. I will talk about thumb. What thumb? And with this function, I can write a value to a register. Okay, what's the argument of this function? Value and register address. Okay, value and register address. I can write a specific value to a specific register by address of this register. Okay, let's see where's this function. In the previous part, I created a project in first CMSIS directory, and I put CMSIS and device from CMSIS to my project directory in CMSIS core and include. You have a header file for your compiler. For example, here for GCC, CMSIS GCC. You have for another compiler, for example, ARM Clang, ARM CC, and other compilers. Okay. But let's open a header file for my compiler. Here is my compiler that will be added on my project automatically, and search for underscore STRT. Okay, here is a function. It's a inline assembly function. I will teach you what's assembly function. You don't need to know what's this part now. You should need to use this function. It's a void return function is underscore STRT, and you can write a value to a specific address. Okay, with this function. And because I've added CMSIS to my project, I can use this function in my code. Okay, in my main program. So now, what is for this function? What is register address? Okay, what's register address? Register is many of them is a 32-bit part of your RAM. Okay, 4 byte of your RAM, and the register address is the address in your memory. Okay, so how can I find my register address? For example, for RCC and AHB1ENR, how can I find my register address? Each register address has 2 parts. Okay, one part is base address and another is offset address. What's base address? Base address of your peripheral. Base address of its peripheral. Okay, for example, here base address of RCC, or in these 2 registers GPIO. Okay, base address of RCC and GPIO. And another is offset of register from base. Okay, offset of register from base, and after that register address equal to base plus offset. Okay, in this way you can find your register address. Let's give some example from some microcontroller. For example, for my microcontroller STM32F746, it's the reference manual of my microcontroller. You should download the reference manual of your microcontroller. Okay, and for this register, how can I find the base address of peripherals? Okay, you should search for memory map. Okay, memory map, memory organization, and in this part you can find base address of your peripheral. For example, for RCC, address of the memory address of this peripheral is from this address to this address, so base address is here, 0x40023800, hexadecimal address of this peripheral, base address of this peripheral. So the base address of RCC is here, and base address of GPIO is here. Okay, is here. So after that, how can I find the offset address of a specific register, Okay, another time, for example, search for GPIO. Here is general purpose IO section. Okay, and in register part, where is register part? Here, GPIO registers. Okay, 6.4, part 6.4. You can, for example, for model register. Okay, for model register from GPIOI, the offset of model register is 0. Okay, the offset of model register is 0. So for RCC A hash B1ENR, the base address is as you can see, and the base address is in memory map. What was the base address? The base address was 0x40023800 plus this was the address. Let's do another time. See memory map. What's another time? See memory map. Memory map and boundary registers for RCC was 40023800. Okay, and the offset of AHBENR is in RCC part. Okay, in RCC part. Let's do search for RCC. I have the page of this address in my datasheet, page 163. Here is AHB1 from RCC, and the offset is 30. Okay, 30. So the offset address is 0x00000030, and the address is 0x400238 and 30. Okay, here is complete address. Let's write it completely here. 0x 00208. It's the address of this register for HB1ENR. What's for modder in GPIOI? First, I should find the base address plus offset. Another time, go to memory map. Here, the base address of GPIOI is here. Okay, 4002 and 2000. The base address is x4002 and 2000. What's the offset of this register? I have the page. In page 208, I have modder register. The offset is 0. Okay, from modder. What's the base address of GPIOI? You can find it in memory map. 0x0000000. Okay, so the complete address is 0x. Here is complete address. And last time for ODR. The base address another time is for GPIO. And the offset is in page 210. Okay, here. For ODR register, this address from base 1414 from base. So the offset address is 0x00000014. So the complete address is 0x4002 and 0014 in hexadecimal. Okay, here is my register addresses. So for this function, I have register addresses. So what's the value and what should I write to this register to turn on LED? For example, for enabling GPIOI clock, what should I write in AHB1ENR? Let's to see the register. Okay, let's to see the register. Let's to write the values in new page. Okay, for example, value for AHB1ENR. What's the value? Let's to see this register in datasheet. And go to page 163. Here is AHB1ENR. And if I want to enable the GPIOI, here, enable GPIOI, I should write a 1 in this bit 8. Okay, in bit 8. As you can see, in bit 8, IO port clock enable. Okay, in IO port I clock enable. Write 1 to clock enable. Okay, so I should write a 1 in bit 8. How can I should write a 1 in bits 8. This means you shift 1 8 times. This means write 1 in bit 8. Okay, for modder, and go to page 208. Okay, for modder register, if I want to set the pin 1, okay, modder 1 is for pin 1 from GPIOI. Okay, from GPIOI, because base address is for GPIOI. Okay, I should write 0, 1 to set it as a general purpose output mode. Okay, in output mode, I write 0, 1 in this register. Okay, I should write 0 in bit 3 and 1 in bit 2. So I write 1 in bit 2. I should write 1 in bit 2. Okay. It's a shift operator in C and C++. Okay, it's shift operator. And for DR, I should put 1 in register output in page. Then I have ODR. To make the output as a high level output, I should write a 1 to this bit, to bit 1. Okay, I should write 1 in bit 1. I should write 1 in bit 1. Okay, I should write 1 in bit 1. So in this way I can turn on my LED on my board. So how can I find the register address, for example, in other microcontrollers, for example, in MX1064 microcontroller from NXP? How can I find base address and offset address in this microcontroller? In this time, search for GPIO. Chapter 12 for GPIO. Go to register description here. Register description. Here. Register description. Here is GPIO register description. To find base address for GPIO-N, you can solve this equation. Okay, for example, for GPIO5, here is base address of GPIO5. And what's the offset address? All offset address come in this table. Okay, for example, for DR, data register, direction register, as an input or output, or other register, interrupt register. Okay, for example, in this microcontroller, you can find the base address and offset address in this way. Or for example, for another microcontroller from NRF, let's go to GPI peripherals and peripherals per GPIO, part 6.9. How can I find the base address and register here? Okay, the base address, for example, for port 0 is here, and for port 1 is here, and the register offset is here. You can find register addresses, offset is in this table, and you can find your base and offset address in all of microcontrollers datasheet and reference manual. So now, how can I use this address and these values with this function? Let's bring function from core, indicate gcc. Here is function. Let's copy the function, and here my project and main. Let's paste it in my project and make it as a command line. So let's write my code. First, I should enable the clock __SRT, and first I should write the value. The value is 1 shifted 8 times. Okay, it's the first value. As you can see, the first value is 1 shifted 8 times. And what's the address? The address is 0x 40023830. Okay, here is address. As you can see, here is the register address. Here is the register address. But I should do a type casting to this type. Okay, to prevent warning in your compiling. Okay, because it's a pointer, volatile pointer, 32-bit pointer, and I should do a type casting. And for mother register, I should write 1 shifted 2 times. And what's the address? Another time. The type casting operation and the address 0x 40022000. Okay, here is mother. Here is mother address, and I should for the last line I should write this value to this register. Sorry, here I have some problem. Here 2. Okay, I should write this value to my register. The value to this register. Another time, underline str, and the value of 1 shifted 1 time in sorry 0x 40022014. Okay, here is my program to turn on LED. After that, write a contentless while. Okay, contentless while. Okay, here is a completely practical project, completely practical code, and with this code, I can turn on my LED. Let's just save that. Save the program and open terminal. I'm in first CMSIS project. Make clean, and another time make your project. I have an error in my code. While I think I should write while 1, for example. Let's just save that, and another time make my project. Okay, here my code is compiled and I have my output. Okay, I have my output. So how can I write my output ELF file to my microcontroller? Okay, how can I and known as flashing, how can I flash my microcontroller? Before that, I should give you some information about flash and debugging. Okay, about flash and debugging. So now I should write output file to chip, flash my chip, and debug my code. I should give you something about GDB and debugging. GDB and debugging and flashing. As you can see, we have worked with GDB for debugging my program in my computer. Okay, for debugging my program in my computer. For example, assume it's your PC. Okay, it's your PC, and you have run your program in your PC, and in your PC you have your GDB program. Okay, here is, for example, your PC or your laptop. It's your program, and it's GDB. Okay, if I want to debug my program in my computer, GDB and my program, all of those both are in my computer. Okay, and with running GDB I can create a connection between my program and GDB, and I can debug my program. And how GDB debug my program? Some system called, for example, ptrace. Okay, with some Linux and operating system called, for example, ptrace. Ptrace is a system call, and with ptrace you can has access to a program register and memory addresses and other things. Okay, for example, in this program GDB with ptrace can debug your program, and GDB and program both are in your computer and run in one operating system in your computer. Okay, so in this scenario, GDB and program run in your current PC or laptop. Okay, that's in, for example, in Linux operating system. But let's talk about another scenario. For another scenario, assume that you are a programmer, for example, in London. Okay, assume you are a programmer, for example, in London, and it's your PC, and you write a program for one of your customer, and for example your customer is in New York. Okay, for example, assume that you are a programmer and it's your PC. It's it's your PC. You are a programmer and you are in London, and it's your customer PC, and he or she is in, for example, New York. Okay, and you have written a program for your customer. You've written a program for your customer, but your computer is in London and your customer PC is in New York, and your customer have some problem with its code and want you to debug its program, his or her program. Okay, so how can I debug this program? There is a way to travel to New York. Okay, there is a way to travel to New York, and it's a dummy and silly work. So how can I debug this program in New York from London? You can run GDB. You can run GDB in your computer and debug your customer program in New York. So how can you do that? With a program that's known as gdbserver. A program known as gdbserver. With gdbserver and GDB, you can do a remote debugging. Let's do, for example, search for gdbserver. You have gdbserver in your computer, and you can debug your customer PC. For example, your customer PC is in London. Okay, is in London, and with internet connection that has between your customer PC in New York and your PC in London, you can debug your program in New York. Okay, so how can you do that? GDB and gdbserver have a a specific protocol from GDB, and it's known as RSP protocol. RSP protocol stand for remote serial protocol. Okay, RSP create a connection between GDB and GDB server, and you can send your command from GDB to GDB server, and in this time GDB server give the command to program. Okay, here you can send with RSP, and in this time GDB send your program. Send your command to your program with ptrace. Okay, and in this way you do not need to travel to London. Okay, with RSP protocol you can create a connection between your GDB and GDB server in any part of world. Okay, in anywhere. So how can I use this scenario to compile and flash my microcontroller? Another time. Assume that you have a PC. Okay, assume that you have a PC and you have a microcontroller unit. Okay, you have a PC and you have a MCU, and with RSP protocol I want to debug and flash my program. Another time you can run GDB in your PC. Okay, it's for example ARM GDB, a debugger for ARM microcontroller. I can find it here. ARM GDB version. Here is the debugger GDB, GNU GDB for ARM embedded. Okay, for ARM embedded. And how can I connect my debugger to my microcontroller? You need a GDB server. Okay, you need a GDB server, but in this time to your computer, you can run GDB and GDB server in just one computer. Okay, in this time I should run a specific GDB server. Okay, specific GDB server, and the connection between GDB and GDB server another time is RSP. So how can I create a connection between GDB server and MCU with a device that you know what's that? A debugger or probe. Okay, a circuit debugger. For example, J-Link, ST-Link, U-Link, OpenSTA, and other programmers. Okay, with this programmer. So with RSP, you create a connection between ARM GDB and your specific GDB server. Okay, your specific GDB server, and your specific GDB server create a connection between itself and debugger with a serial protocol. For example, many of time USB serial port, or for example Ethernet port or other port. Okay, and your debugger create a connection between itself and MCU with some specific serial port, for example JTAG or SWD. So debugger give USB serial or Ethernet packet and convert it to JTAG or SWD to compile your MCU. If you want to compile, flash and debug your MCU, you need, for example, in ARM Cortex microcontroller, JTAG or SWD. So debugger convert this packet to this packet and vice versa. So it's a scenario. You should create a connection between your specific GDB server and ARM GDB. You should connect your debugger to your board, and for example, by USB to your computer, to your PC. Here is your PC, and run GDB server and GDB, and flash and debug your microcontroller. So what is this specific GDB server? Each debugger has its GDB server. For example, J-Link has a J-Link GDB server. ST-Link has a ST-Link server. ST-Link GDB server. And if you, for example, have ST-Link or J-Link, you can use this GDB servers. You can download these GDB servers and use that. But there is some GDB servers that you can use with all of debuggers, with almost all of debuggers. For example, one of that is OpenOCD. Another is pyocd. In this time, I want to use pyocd because it's compatible almost with all of debuggers. And if you have, for example, J-Link, ST-Link, U-Link, OpenSTA, and other debuggers, you can use pyocd and run a GDB server. Okay, pyocd and run your GDB server. For example, and in this time, let's open my web browser, and for example, search for J-Link GDB server. You can download J-Link GDB server from Sager website, or for example, ST-Link GDB server. You can download ST-Link server software from ST Microelectronic website, or you can download OpenOCD. OpenOCD is another project, open source project, and you can download it and run your GDB server and make a connection between your board and your PC. But in this time, I want to use pyocd. Let's open that. Here is open source project that have written by Python. That has been written by Python, and it's in GitHub. Let's open that in GitHub and download and install and use it. To first flash my program to my board to turn on my LED. Okay, here is GitHub website and pyocd repository, and you can install pyocd from this page. As you can see in documentation, it's documentation readme file. This GDB server and this program can work ARM Cortex-m microcontrollers, okay, using USB debug port, okay, and it can work in Linux, Mac, and Windows, okay. And then they allege that their GDB server and their program work with all of microcontroller in the market, almost all of microcontroller in market, because it's based on CMC spec. It's based on CMC spec. You can study about CMC spec and a specific file in CMC spec. First, let's open CMSIS and go to CMSIS website, and you can study about CMSIS documentation. You can study about CMSIS documentation in this website and about CMSIS pack. Okay, what's CMSIS pack? What things are in CMSIS pack and how you can create a CMSIS. You do not need to create a CMSIS pack because this pack has been created almost by chip manufacturer. Chip manufacturer needs to create this pack, and pyocd use this pack to use for debugging and flash your chip, and it has some information about your chip. Okay, and you can use pyocd with NXP LPC link, NXP MCU link, Atmel ICE, CMC stat, DAP link, Cypress kit, KLU link, Segar J link, SC link version 2, version 3, and you can see pyocd is compatible with a lot of debuggers. Okay, a lot of debuggers. So how can I install that? You should first download Python 3, and with this command you can install that. Okay, and if you want to download and install it by yourself, you can first run this to download that from GitHub and install your install pyocd in your computer. But you can just by this command can download and install pyocd in your computer. So now I have pyocd in my computer, and if I type that without any option, you have some commands, some help from pyocd. For example, you can use flash to program an image to device, or erase to reset your device and erase the information and the code from your device. Okay, or you can write pyocd with gdbserver or gdb server, right, identical to run a gdb remote server. Okay, so with pyocd you have a gdb server. And for example, pack to install a microcontroller information and a pack for your device. But first you need to install and download pyocd. First you install pyocd. After that you can write a command with some option, list and target. It gives you some information. About supported device. Okay, let's write pyocd list underline hyphen target. In my computer, pyocd support these microcontrollers. Here is built-in means is pre-downloaded by pyocd, but pack means downloaded by pack command, by pack option. For example, for my microcontroller F406, here is my microcontroller downloaded by pack. Okay, I've downloaded manually in pyocd. So if you find your microcontroller and your board in this list, you don't need to download a pack for pyocd. But if you don't find your microcontroller, how can you do to add your microcontroller and your board to this list? First, plug your board to your computer. Plug your board to your computer by a USB cable. Let's open the webcam. Okay, here is me. I'm Salah. Okay, here is my board. Okay, here is my board, and you can see here I have a LED that is off, and I want to turn on this LED on my board. Okay, first plug your board to your computer. Here I've plugged my board to my computer. Red LED means you are plugged and you have power on your board. Okay, and here is a RGB LED, and now is red. Now it's red. Means that you don't connect your board to a GDB debugger. Okay, still I don't connect it to software. So when you connect your board to your computer, type pyocd and list. Okay, now pyocd has identified my board, Discovery F from STM32, and it's my microcontroller name. So how can I add a packet for my microcontroller? If you don't have in the list of pyocd, you can write pyocd pack. First you can find for your microcontroller. Okay, first before that you can find for that and paste name of your microcontroller. Okay, you have a package and it's installed. Okay, it's installed before. So if you want to install this package, you can type install and it will automatically install this package on your computer. Okay, on your computer. Now in this way I can add my microcontroller to pyocd. So now pyocd recognized my board. How can I flash my program to my board? Here I don't have a green LED on my board. Let's do program my code with pyocd. Okay, as you can see, I have my output.elf with pyocd flash and name of your output file. You can write output file to your LED. Let's put it here. It's my board, and let's press enter. Oh, sorry. No. Here. Let's minimize it here. Here is my board, and press enter. Now that I have a green LED turned on my board. Okay, reset that. I have a green LED turned on my board. But was it worth it to do a lot of things to just turn on a green LED on my board? Yes, worth it, because now we have a lot of information about GCC, GDB, and we have a deep information. I could do it just with a simple IDE like STM32Cube IDE, but in this time I have deep information, and I can use this information to write a very good program for example, a real-time operating system. Okay, now I've turned on an LED on my board. So how can I erase a program? I can write pyocd erase and chip. Okay, chip. If you write just chip, it will erase just your internal flash memory on your chip. But if you write, for example, mass, and pyocd has information about other external flash on your board, it can write all of flash memory on your board. Okay, You can write in documentation about this commands. It's so easy commands. So now, how can I run this scenario, run a specific GDB server and debug my program? Debug my program. Let's do first. I know you love me. Let's do close that. And now I can debug my program with pyocd. For that, let's open a terminal. Run pyocd and gdb or gdbserver. GDB is alias name for GDB server. Okay, you can run pyocd and gdbserver and press enter. Now, as you can see, let's do another time. Now this LED is green and it shows you connected a circuit debugger program to your board, okay? And sometimes it's blinking between red and green. But if it's red for this board, if it's red, it means you didn't connect and you don't connect and you have not connected software to your board. But it's green and it means pyocd is connected to my board. Okay, now I want to debug my project. Okay, now here you can see an important number. GDB server started on port 33. Okay, as you can see, I should create a connection between ARM GDB and GDB server with RSP protocol, and RSP protocol can run on internet or, for example, a TCP connection with a port. Okay, if you want to, for example, here connect from a PC in London to New York, you can write the IP of this PC. What's the IP of this PC? You can give the IP of this PC from your customer and create a connection between GDB and GDB server with the IP of this PC and a port. Here is 33 port. Okay, but in this time I run GDB and GDB server in just one PC, and it's a locally connection between ARM GDB and GDB server. So I can give the IP of my current PC. What's the IP of my current PC? There is an IP that known as loopback IP or your current PC IP, and it's known as 127.0.001. Okay, let's see. Okay, it's IP of your current PC in all of operating system, but you can write local host instead of your IP. Okay, local host means IP of your PC. Okay, so now I've run GDB server. Now I should create a connection between ARM GDB and GDB server. For that, you should run ARM GDB. Okay, GDB. I've downloaded dashboard to make my GDB more interactive, but it's better to don't use ARM dashboard with GDB. But if you want to use dashboard for GDB, you should write ARM GDB Py. Okay, it's another ARM GDB that can, for example, run dashboard. Okay, I've downloaded dashboard for GDB and refer to GDB part to know what's dashboard. Okay, but now I run just ARM GDB because I don't want to use dashboard. But if you want to have a more interactive and more beautiful GDB and debugging for your microcontroller, you can run your GDB in text user interface. This option make your GDB and debugging more interactive. Okay, but you can don't use that, but it's better to use that, and run output.elf. Okay, output.elf. Now try to type C to continue, type C and press enter. Now I have my program here, but I've still not created a connection between GDB and GDB server. Okay, how can I create a connection between GDB and GDB server? In this time, you should write this command: created connection between GDB and GDB server. Target. You should write target to introduce a target to GDB. And what's target? My target is a remote target. Okay, remote target, because I want to use GDB. IP of your GDB server. In this time, local host and IP of your GDB server. You can change your IP in some configuration in pyocd, but you don't change that. 3333. Okay, with this command I can create a connection between GDB and GDB server. You can if you have a local host connection, you can just write your port without the IP. Or for example, you can write, for example, 127.0.0.1. okay, all of this option is true. Okay, so let's write that in GDB. Target remote local host colon and port. Okay, now if I press enter, I have a connection, remote debugging, using this IP and port. Okay, I have a connection between my board and my GDB server, with me GDB and GDB server. So for example, I can load my program and flash my program in GDB, and you should write load and your output file. Okay, in this time. Another time, let's minimize that, put it here, and let's create my board here. Okay, here is my board, and I can another time load program on my board. Blinking here means you do some works. Okay, now I've flashed my board another time, and as you can see, I'm in reset handler in my startup file. Your code will start from reset handler, branch to system init to do some system initialization, and after that do some other things, and branch to main. Okay, where is main? You can find main. I don't know where is main. After that, branch to your main. Okay, now let's do something. For example, add a breakpoint to main function. Now I have a breakpoint to main function. If you write C to continue, now you are in main function. Okay, and as you can see, my green LED is off. Okay, because my debugger should run these three commands to turn on my LED. Let's create another breakpoint to line 7. Breakpoint to line to main.c and line 7. Now I have a breakpoint to this line. if I press continue, I can turn on my LED. See my board. See my board here. And if I press C to continue and press enter, now I've turned on my LED and I'm debugging my board. But because this function is inline function and you can't debug them easily. Okay, you can't debug them easily. And how can I reset my board? How can I reset my board? You can't use a start with pyocd, but for example, you can use it with OpenOCD or ST-Link. You can some option to use with another gdbserver, but with pyocd you can't use a start. So how can I reset my board? I can use monitor command. Monitor command is a command from GDB that send some command, a specific command that's related to your target. Okay, some specific command that's related to your target and your GDB server. Send some command to target or GDB server. What's this command? Let's go to OpenOCD, go to documentation. Here you have command reference. You have some commands here. For example, a command is reset command. You can use reset to reset the target. Okay, so how can I send reset? You should reset target. You should use reset target with some options, reset and halt. Okay, because you want to reset your program and stop in the first of your program. Okay, reset and halt. If you write monitor or in a abbreviated form, just mon, and reset and halt option, you can reset your board and stop in the first of your program in reset handler. Okay, it will take you to reset handler. Let's run monitor reset halt. Okay, monitor reset halt and press enter. Now restarting target with halt, successfully halted device on reset. And if another time press C or continue, you are another time in main. If I press S, another time S and S, I'm another time in main function. But because I'm using this function, and these are inline function. What's inline function? I will teach you what's inline function. But this function have some problem with debugging. Okay, so I'm in line 5. If I press N to next, press N. Okay, press N or next and press enter, I can't use the next in proper way. Okay, I should another time run I mean SRT function, another time S to back to my function. Okay, so how can I resolve this problem? Let's quit the GDB. Press. If you quit and close from your GDB or disconnect from your target, the pyocd will be closed automatically. Okay, will be closed automatically. But let's go to my main function and create another function. What's function? It's an API function and it's a covering function, a void function, for example, write register. Okay. What's the argument of this function? Just like srt. Just like srt. Okay. So what should I do in this function? I should do this. I should use this function. Okay. And instead of srt, sorry, underline srt, you can use write register in your code. Okay. You do not an important thing, but in this time you have a C function, not an inline function. Okay, as you can see in CMCGCC, it's a inline function. Let's do copy that, Control F, Control V. Where is the definition? Here is definition. It's a inline function. Okay, static inline function. But when you have an inline function, you have some problem with debugging. Not important problem, but it can bother you. Okay, but in this time I've covered the srt function with a non-inline static function, and I can debug my program better. Okay, my program better. Now, in this time, let's do save that, and another time make my project. Control L, make my project. Let's do another time run pyocd gdbserver. I can write gdb for gdbserver. Port 3333 another time, and let's do run ARM gdb gcc in TUI mode and output elf. Sorry, gdb. Press C to continue. Let's to create a connection between GDB and GDB server remote. I can just write port because I use GDB and GDB server in just one piece. Press enter. Now I have a connection between GDB and GDB server, but another time let's to load my program. Load output.elf. Now I have output.elf in my board, and another time let's to create a breakpoint in main function. Now I have a breakpoint in main function and continue to main. Now I am in main function. Okay, in this way I can use easily next or end command in GDB. Okay, and enter, I'm in next line. Let's do. Okay, in line 7 I can enable GPIO clock. Another time press N and press enter. In line 8 I can make my GPIO output, and if I another time press N and press enter, I can turn on my LED. I've turned on my LED on my board. Okay, I've turned on the LED on my board. So in this way you can easily debug your board, or if you have another time run info from your registers, you can write info register and you have info from your registers. Okay, you have info from your registers. Okay, you have info from all of your registers. So According to our agreement, I've turned on an LED on my board and debug my program. Now I can debug my program, my practical program on my board with GDB and gdbserver. What's GDB and gdbserver? It's the scenario. It's the scenario of GDB and gdbserver. If you want to create a connection between your GDB and program in your PC, you can use ptrace function, but in your microcontroller, you can first create a connection between your debugger and GDB server, a specific GDB server, for example, here pyocd, and after that, create the connection between your computer and your microcontroller by your debugger. Okay, by your debugger. Now I've turned on an LED on my board, and thank you very much to see my project. In the next part, I will give you some information to config text user interface, graphical text user interface, to do our works in a graphical user interface instead of terminal. Okay, since from I want to do my work in a graphical user interface. Thank you very much to see me, and see you soon in the next part.